This is part 2 of section 4.1. We've already talked about testing ordered pairs to see if they were a solution of a system of equations. And we've done one by graphing. I've got 2 more examples to do by graphing before we move on to substitution. So number 12. Like we said earlier, with the graphing, it's preferred that you write them side by side so that you have room to actually solve them for y and get them in slope-intercept form. Okay, we have our 2 equations. Probably good for me to get a piece of grid paper to do this, but this is what I got. So on the first one, y-intercept is -6. 1, 2, 3, 4, 5, 6. When you're doing this, it's important to try to keep the spacing the same between your scale marks. -6 is right here. The slope is 4, so when I move over 1, it should go up 4. 1, 2, 3, 4. I'm going to go ahead and put another one and go up another 4. And now I'll draw my line. Okay, second equation is y equals x, so the y-intercept is 0. The slope is 1, so every time I go over 1, I'm going to go up 1. And I've hit one of the points already, so that's good. I'll draw a line. There we go. Looks like it's at 2, 2. As we said earlier, with graphs, it's not always so real dependable on knowing if you're actually on a grid mark or not. So if you want to check your solution, 2 minus 2 is 0, and 4 times 2 is 8, minus 2 would be 6. It works as far as plugging it back in, so it's got to be a solution. Number 14. I've got 2 more that aren't in slope-intercept form. I'm not sure that graphing would be a good method to use if it's not already in slope-intercept form, or at least reasonably close. I think the book is just having you do this just so you can practice graphing, probably, and to get the concept across. But normally, if you're having to go through this much work, it might be better off to use one of the other methods. But we'll play along. Y is equal to 1/3 x plus 2. On this one, minus 3x. Uh-oh. Positive divided by negative is negative. Okay, well, the numbers aren't real big and bad, so hopefully this thing will work out nicely. I don't know about if you've noticed, but I just noticed the slopes are the same. That tells me something that I learned on one of my earlier lessons, but I'll go ahead and try to graph it and play along here. The y-intercept is 2. The slope is 1/3, so when it moves over 1, it should go up 1/3, which It is hard to see, so let's project it on out. We'll go up 1 over 3. There we go. Let's graph the next one. The y-intercept's -1. Slope is 1/3 again, so when I move over 1, it'll go up 1/3. Or I could go up 1 over 3. When I connect the dots, you'll see it's parallel. And that's, well, I didn't do a very good job drawing that, but anytime the slopes are the same, they're going to be parallel. Now, this is called an inconsistent system of equations because it has no solution. If it has no solution, we can write that it's the empty set. We could write no solution. We could say it's an inconsistent system of equations. Okay, so that's it for using graphing. The next method we're going to talk about is substitution. It's a little bit more involved. Usually the best time to use it is when one of the equations is very easy to solve for either x or y. So like this one's going to be, well, it's already solved for x. It's going to work out nicely. This one wouldn't be hard to solve for y. This one probably wouldn't be hard to solve for x. Substituting is going to be ugly if we use the fractions. We'll have to deal with that. But that's going to be easy to solve for y. So, all right, the method goes like this. I'll do number 16 as the first example. One of the equations has to be solved for either x or y. So I'm going to solve the second one for x because it's already solved for x. I always put a box around what x equals. And the reason why is because what's in the box is what I'm going to substitute for x in the other equation right there. So 5 times x, which is 3y, plus 2y equals -17. What this does, it gives me only one equation to have to solve for instead of having two. 5 times 3y is 15y, plus 2y is equal to -17. 17y is equal to -17. Divide by 17, and it looks like y is going to be -1. Now that I know what y is, back up here where I had the box drawn, the box is also handy to help me know where to go back to. I can plug -1 in for y. So I get x is equal to 3 times, I'll draw a little arrow here to show that that's where I'm going, and I'm using this right here. 3 times -1. 3 times -1 is -3. That's what x is. So the ordered pair that would be a solution for this is -3, -1. I could test it. I could put the -3 here and the -1 here, and that would be true. I could put the -3 up here and get -15 minus 2 would be -17. So this is the solution. Let's see if maybe I've got time to work one more. I'll do number 18. I'll try to work quickly here since I only have about a minute. Over to the side, I'm going to solve this one for y. Here's what y is. Now I will substitute that for y in the other equation right here. So negative 4x plus 2 times 3x minus 6 is equal to negative 8. Now I'll solve this equation for x. And it looks like x is going to be 2. Now that I know what x is, I plug it back into the equation up here, inside the box. 3 times 2 is 6, minus 6 is 0, so we end up with y equals 0. And the solution is 2, 0, and yes, that works out plugging it in to make the equations true.